Alright, so we are looking at solving exponential equations. These are equations where our variable shows up in the exponent somewhere. And the key here is to use your exponent rules, the ones we just discussed in the previous video, to rewrite your equation so that you have common bases. If you have common bases, recall that you could then just set the powers equal to one another and drastically simplify your equation. So what am I talking about? Well, let's take a look at our bases. I'm talking about 1/3 and 9. We want to try to use our exponent rules so we can rewrite those as some number, okay, that is common to each. Well, usually your choices are going to be either 2, 3, 4, or 5. Okay, you're not really going to ever see anything other than those values for a base. So if we're talking about 1/3 and 9, hopefully the number 3 is jumping out at you. 1/3 is really 3 raised to the -1. Right? Remember, this 3 down here really has a 1 for the power. So 1/3 is 3 to the -1. Alright, and then all of that is going to be raised to the power of x, okay, because we see that x from up above. Now, this 9, well, that is 3 squared. Okay, 9 is the same as 3 squared. So notice I have a base of 3 now on each side. Don't forget we still have this 4x plus 1. So now we have to use more exponent rules. We're going to need to multiply our powers here since we have a power to a power. Now since we have a common base of 3, we can essentially ignore it. Okay, so we have -1 times x, and then when we distribute here, we're going to have 8x plus 2. Let's subtract over 8x. We're going to have -9x equals 2. So then x is going to be -2/9. Okay? So when we have the same base like this, we can ignore the base of 3, and we're able to then just set the powers equal to one another and then just solve for your variable. Okay, in our next example here, we are looking to solve 3 times x raised to the -3/5 equals 24. Now this is not an exponential equation. Notice our x is not an exponent, but it is going to involve some exponent rules. So we are looking to solve for x, so that means we want to get x alone. Well, you see that 3 in front, so we can divide that 3 over into that 28 and get 8, or into that 24 rather, and get 8. So we're trying to get x alone, and we have this power of -3/5. Okay, so the thing to understand here, the concept to understand here, is if we want to get rid of a power like that, so that x would be alone, we really want that power to become a 1, right? If we can get this to be x to the first, then that's just the same as x. So ask yourself, well, what can I do here to this power so that it becomes a power of 1? Well, remember, when we have a power to a power, we have to multiply. So if we were to multiply by the reciprocal, okay, which would be 5 over -3, now what I do to one side, I must do to the other side. But if we raise each side to the reciprocal power, what we would have here, if we multiplied straight across, all right, if we look at this, we'd have -15 over -15, which just becomes x to the first, right? And then we still have this 8 raised to the 5 over -3. Oops. Okay. So, and that negative you can put anywhere. Okay, you can put it with the 5, you can put it with the 3, or just in the middle somewhere. All right. So let's first just jot down this whole reciprocal power idea. Okay, so to make a power 1, remember, you're going to just raise it to its reciprocal. Okay, so you're going to just simply flip it. All right, keep the sign the same. It's not an opposite reciprocal. Okay, we're not negating it. So to figure out what x is equal to, let's assume you're not allowed to use a calculator here. If you recall that you can turn a fractional power into a radical, Great. Okay, so this would be 8 raised to the negative 5, all of that cube rooted. Or, more than likely, you are not going to remember that, and instead you can rewrite 8 as 2 cubed. Okay, this is, in my opinion, the easier of the two ways of approaching this without a calculator. Okay, so this is going to be a clean number if you're doing this without a calculator. Okay, so this base of 8 we know is 2 cubed. If it were a 7, you can't do it. You couldn't go any further. Okay, these 3's will cancel. We're left with 2 to the negative 5. You're expected to go further with that. That is not negative 10. Okay, it's not 1 over 10. All right, instead it's 1 over 2 to the positive 5. Remember your exponent rules for negative powers, and that's 1 over 32. Okay, so your x is equal to 1 over 32. That would be your solution. Okay, so we can put it in a solution set. Alright, but that's what we would have when we simplified it all the way down. So expect to be able to do problems like this without a calculator.